So you should have done some reading on ray tracing and what ray tracing is, how our eye perceives light, and then how we calculate it using a computer. It's essentially the opposite effect. We're going to shoot rays out of this camera, and it's going to intersect within this area here and calculate what each pixel should look like. So to do that though, I'm going to add a mesh, a plane, and scale that up. Bring this to sit up on top of that. I'm going to add in a mesh, a UV sphere, bring that to the right, bring it up. This can float a little bit, that's okay. And for this one, I'm just going to tab into it and hit subdivide twice. No. I'm just going to use a subdivision modifier, okay, and change it up to render 3. Then I'm going to add in a mesh, a cone. Bring that cone over here and sit it about there. Now with these 3 things done, I'm going to change this shading to smooth on these and go and add some material. So this material here on the square, I'll make it blue. This material here, I'm going to make it red. And this material here, I'm going to make it green. And then this material here, I'm going to make black. But I'm going to add mirroring to these here. So mirroring down the bottom, I'm going to turn its reflectivity up to about that. And leave it at that. This one, I'm going to turn it mirroring on, but just a slight bit. This one mirroring a bit more. This one's going to have mirroring on it. This is going to take a little while to render, by the way. And it'll give me a little preview of the texture up here. Now with that done, I should have a light source here, which is set to lamp. I'm going to leave it at point light, and it's going to be set to ray shadow. Okay, so it's actually going to cast rays to determine where the shadow is, but I'm going to turn the number of samples. Actually, for my first one, I'm going to leave it on 1 sample. For my render settings, I'm going to go ambient occlusion, environmental lighting, set those to multiply. I don't need to worry about the sky here. Down here, for my very first render, I'm going to click approximate, and we're just going to leave it at that. Then I hit F. I'll go back to here. I can leave this at 50%, and I'm going to hit F12. That's going to do a pretty quick render. Now when that's done, I'm going to click Save As Image, and I'll just save it to my desktop as sample 1, Save As Image. So now I'll go back to the 3D view, and I'm going to turn it on to Ray Trace, and I'm going to turn it down to 1 sample and hit F12. Okay, you'll see with 1 sample, I've got a lot more things happening here, shadows and stuff that are occurring, but it's very, very, very grainy. So I'm going to save that, Save As Image, sample 2. And I'm going to go back into here and turn the number of samples up to 10, hit F12 again. Now you'll see it takes a lot longer to render this time. It's still quite grainy. However, in a sec, you'll be able to see these side by side. And there should be quite a notable difference between them. If you don't turn the reflectivity of this up to 100, you'll get better shadows. I can see the shadows here, but because it's reflective, the light source is also coming out of there as well. So that makes a bit of a difference. So I'll go Image, Save As Image, Sample 3. Now I'm not sure how this video compresses stuff. So if I just go and open those images, they should be on my desktop. Sample 1. Sample. Okay, so that's approximate. It doesn't quite have the same depth as this one here. Okay, so this has got a lot more depth in it. Okay, so we'll go back to this one here. It still looks pretty good, approximate, but this is with one sample. So one lot of rays through every pixel, and it just calculates it very quickly. And that's with 10. Okay, now this may not be the best thing. I'd probably want to move that ball in so I get more of the reflection there. Move this in so I get more of the reflection on that. Kind of like, well, I'll just do it very quickly. Move that into there. Move that into there. And then hit F12. And I'll be able to see the reflections in here a lot better. There is one more thing you can do to make a big difference, and that is under the, now I found it once before. It's not shading. I think it might be under the sun settings. Nope. I can't seem to find it now. Oh no, it's in the materials. It's subsurface scattering. If you put subsurface scattering on, so say if I, that looks a lot better now. If I turn subsurface scattering on this object, for example, go to the material and subsurface scattering. Don't really need to play around with these settings. I can just pick something like milk. It doesn't really matter. And then if I hit F12, it will take care of that first, and then it will calculate that in here. It's only going to give me a subtle improvement, very, very subtle, but it will be notable. Okay, you can see it'll be notable once we see the edges of the shape. Okay, the edges of the shape are a little bit blurred, where the light has subtly infiltrated the edges of it and gone around. Down here, it's kind of made a glow effect, and that maybe because it's slightly poking through the model. Okay, but that subsurface scattering will improve what it looks like in some ways. Okay, so that's how you can make a render to demonstrate ray casting. So if I just go back to, that's with 10 samples, and it's quite noticeable if I go down to one sample. So that was on the world settings, one sample. F12. Okay, it's very, very grainy compared to it. Oops, that should have been up at 10. I'm not sure why I changed that. Okay, it's quite grainy, especially around here compared to it. You may need to even zoom in on the image to show the grain in the final one. Okay, you can see the grain there compared to 10 samples. If I do that and hit F12, just let it do its thing here. When you zoom in on it, there's not really any grain at all. Okay, you can go up in samples. There's no real limit. It just processing power. It's going to take a lot longer, and that's something else that you'd want to talk about as well. Okay, so this kind of shading can't be done in real time. So you couldn't have a game that was fully ray traced in real time. It just wouldn't be possible. It would take too long to compute it all.